Okay, question 19. So the distribution of scores on an examination is a continuous random variable x and has the probability density function defined by this between 0 to 100. The top 7% of students in the examination will be awarded a high distinction. Determine the minimum mark required correct to the nearest unit to be awarded a high distinction. Okay, so what it's actually asking us to get, it's saying these are continuous random variables. So if we were going to be looking at the normal distribution of this, where is that 7%? So I'm going to start first by working out my mean and standard deviation, and then I'm going to use my mean and standard deviation in the statistics function, and I'm going to use the 0.93 to work out where this mark lies. So where is my little thing? So if this is 7% here, then what is the score that aligns with that 7%? Okay, so let's start by working out the mean. So to calculate the mean of this continuous random variable function, we're going to be integrating pi over 200 sine bracket pi x over 100 between 100 and 0. We're going to multiply this by x, and we're integrating with respect to x. So when I throw that in the calculator, integrating shift pi over 200 sine bracket shift pi x over 100 brackets. Now I'm going to put this whole thing in brackets so I can multiply it by x. Bracket. We're putting 100 up there. Ooh. Okay, bear with me. I am just entering the function in as we've written it over on the other side. It's just takes a lot of clicking to get where you need to go, apparently. Okay, execute. Okay, so that gives me 50. So what we found is the mean score of this function is going to be 50, which means that if I'm looking at my thing like that, the mean is at 50. Okay, so now I want to work out the standard deviation. So I'm going to take the square root of the variance. So I'm going to take my mean from up here. I'm going to use this, and I'm just going to throw it into the formula that's given to us for continuous random variables. So I'm integrating our function from 100 to 0, bracket pi over 200 sine pi x over 100, bracket x minus 50. Now I'm using this one because it gave me an exact answer. If it didn't give me an exact answer and it gave me an ugly decimal, I'd have to take this answer forward, which means I'd have to re-enter the whole thing into the calculator. But because it gave me a nice answer of 50 here, I'm just going to adjust it over here. So here where I've got x, I'm going to put minus 50, and I'm going to square that. Press enter. Whoop, that's not good. Okay. Excellent. Let's see what it doesn't like. Aha. Okay. Let's undo that. We've accidentally raised the whole thing to the power. Okay. So I'm just going to add another set of brackets in there, just so that this works out and I don't have to re-enter the whole thing. Okay, so there, that is giving me the answer for variance is the 473.576 3. Remember, 4 decimal places. So I'm going to take the square root of this to get my standard deviation. Now I'm going to square root the answer in the calculator so it gives me the correct thing. So over here, shift, square root, shift, enter, execute. Okay, so then that's telling me that my standard deviation is 21.7618. Okay, so next thing I'm going to do, so now I found out that the standard deviation is of each of these things, the distance between the two bars is going to be 21.76 scores approximately. Remember, we're still trying to find out this little space in here. So I'm now going to go to my statistics function. So stats, okay, distribution, normal distribution. Oh my God, just work. Okay, normal distribution. And we're using the inverse norm because we want to find the score. Now, first thing I have to change is tail has to be left because it's over here and we're leaving the right exposed. So we're going to send our tail left. We're changing the area underneath to 0.93. And if you did the tail right and you worked out the area as being 0.07, you'd get the same thing. Same answer, it doesn't matter. Okay, because technically you're still looking for the same location, just using a different input. Okay, standard deviation was 21.7618. Execute, our mean was 50. Execute. Okay, so that gives me that the score okay, so the score is equal to 82.1159. Okay, so therefore a score of 83 is needed to achieve a high distinction. Now, why is it 83 and not 82? So if you think about our little thing over here, this line there, that is our cutoff for high distinction. Now, that happens at 82.159. If you get a score of 82, you're still over here. If you get a score of 83, then you're over here. Now, we're saying that you can't get half marks or you can't get, point of a mark because we want them to be discrete values in this. Okay? But, yeah, that's it. So a score of 83.